All right, folks, welcome to the DM Radio pre-show here. Your host, Eric Kavanagh with Tony Asaro. We'll get the formal radio show started in just a second, but I wanted to share something with you all first, and we'll dig into this and we'll talk all about DeepSeek, what they've done, why it matters, what's really happening here. But to start us off, I wanted to show this slide just because I love it so much,
Hmm.
and it really blew my mind. And this is a webinar we did, I guess, a couple of weeks ago. So share, and you can find it on the YouTube, all access past the end of data silos. So basically, the webcast delved into, to use a ChatGPT word. I've heard that if you use the word delve, it's from ChatGPT. I like the word delve. I've used it before ChatGPT. I'll use it after ChatGPT.
Ah,
But anyway, this slide shows NAS architectures and hyperscale NAS architectures, network attached storage, of course. On the far left-hand side, you can see 10 hops, and then there's 9 hops and 8 hops and then 5, and then good grief. So this is how long it takes to get data from storage into a GPU. Well, when you're talking about training a model with billions of parameters, that's a lot of data to move. And if you're moving at 11 hops for every single piece of data, that is incredibly expensive, time consuming, and energy consuming. It's all these factors. If you can knock it down to 9, you save some time, 8. And what the folks did at Hammerspace, which has blown my mind, and I think it's extremely relevant for this conversation today, is they're able to create this parallel file system that goes over all of your different file systems, wherever your data is, S3 in the cloud, on-prem, wherever, it doesn't really matter. If the server is using the flash storage that's on the actual compute server, which a lot of times they don't do, and we'll talk about that later on in the show, in part because most of their protocols for governance and security are wrapped around the storage array. Well, in the compute array, you can't even opt out. This is something David Flynn mentioned on the webinar. You can't even opt out of getting these flash drives in your array. So they're attached by NVMe. They're super fast, and he says, look, we you can use that. You can use that storage. So then, just think about it. Then you don't have to hop out to the network. You don't have to go to some external storage array, deal with the controller nodes, all that kind of stuff. All that is out the window. You just go right to the data that you want. So it's just like eating from the platter that's right in front of it. So I wanted to show this slide. We'll get back to it later on in the conversation, but I wanted to just tease you all with that so you can have that in the back of your minds as we talk about this all. And in just a second here, we'll start our formal radio show. Let me get the transcripts running. And thank you so much, all of you, for attending. I know this is a last minute show that we popped up, but I realized sitting in bed the other night, where I get my best ideas, when you have to,
ah.
either get up and write it down or get your iPhone out and do a message before you fall back asleep. I had to do this because I was like, these guys know what they're talking about. All right, so the first segment's about 17 and a half minutes. Stand by. All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh here. We turn 17 years old next week. Next week, 17 years old. I'm turning 57, so I've been doing this, about a third of my life. I've been doing DM Radio, which is exciting and a bit depressing, I suppose. But things are getting so interesting, folks. And today we're going to talk about DeepSeek. What is this thing that just took the market by storm? By some estimates, my good friend Jim Harris, who is on the Twitter universe, now called X, and also LinkedIn, of course. He is a serial broadcaster and creator, incredibly smart guy. He did the math, $1 trillion. Half of that was Nvidia alone. It was like $548 billion lost in market cap. Does that make sense? Well, first of all, don't forget that Nvidia has been going up, 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 up. I mean, sky high. And so a lot of the advancements have been already factored in. But why would this LLM being spun out of China cause so much uproar? Well, the main argument being used is that it was so cheap to train. So we keep hearing how it's so expensive to train these models. You need all these GPUs, all the high-end GPUs. Of course, there are sanctions on China, so they couldn't use the 100 chips. They had to use the 800 chips, for example. I mean, all that is interesting, but does this new LLM really change the game so much that suddenly there's not nearly as much value in Nvidia? Well, according to the markets, yes. I think that's temporary. You already saw it kind of tick back up. But from my experience, processor speed is like internet speed. It's like storage. The more you get, the more you use. You're just going to use when you get it. No one ever is going to want to go back. If you want to do that, just go, get a dial-up connection and just see how fast you go crazy. It's not going to happen. We get accustomed to certain speeds of things, and then you use that. So the argument that somehow Nvidia is worth less, I don't think that really holds water. I think we're going to find out. So we get to the training. That's why I wanted to get the Hammerspace folks on here. They are the experts in training. So what do you have to do to train? You have to get lots and lots of unstructured data into the GPUs. So I'll throw it out for our radio audience. If you hop on YouTube, do a search for All Access Pass on the Inside Analysis channel, you'll see a webinar where we go through all the details of this, and it's absolutely fascinating about getting into the Linux kernel itself. I mean, these guys are so smart. They went out and hired the top 2 developers for the Linux kernel and got into the operating system to create this highly parallelized data path to let data move around at tremendous speeds. So this is unstructured data orchestration. It's a huge part of the equation here, and that's why I wanted to get some of these folks from Hammerspace on the call. So Tony, I guess I'll use that to introduce you, Tony Asaro, Chief Strategy Officer over there at Hammerspace. What do you think about DeepSeek? They've done distillation, which is very clever. It's open source, which I love because now we can all share in the innovation. There's all this talk of, oh, it's a Chinese company, all the data is going to go to China. That's true, but don't think for a second that Google and Meta and LinkedIn and Twitter and all these folks aren't capturing your data and using it for their purposes. They are. This is, it's like the Wild West over here in America. So that's all true. What really is going on here? I think it's really impressive what they've done, but it's still a large language model. It's still going to hallucinate. It still has all the problems that LLMs have. And bigger isn't always better. Even Sam Altman himself said, oh, the era of large language models is over like a year ago. And we're all like, what did that man just say? I think he saw this all coming. But with that dynamic intro, Tony, tell us, what do you think? What's this DeepSeek all about? What's happening?
Well, first of all, I do want to step back, Eric, and say that yes, we have two of the smartest NFS experts on Linux, but there are plenty of other smart ones out there. We don't
Sure.
want to insult the rest of the community,
There you go.
and they are
That's fine.
welcome to be part of the team as well if they want to come work with Hammerspace. So start there.
Absolutely.
Well, I think that first of all, I think that the cost impact got a lot of headlines, but do we have actual transparency into their environment? Until we do, I'm not overly impressed one way or another. So,
Mm,
so yeah, it sounds good, but I don't, other than just telling us what they're doing, I'd like to see what they're doing, and of course, they're never going to do that. So I'd like to understand that more. That's the first thing. So, do we have a reliable narrator or not? That's
sure.
key.
Sure.
The other aspect of it, and let's say it is true, right? I agree exactly with what you just said. Ubiquity of technology actually stimulates economic growth, not the other way around. So commoditization is a good thing. Winners and losers may change, but overall, the macro impact is going to be, in fact, landscape changing. I would also say in this environment, right? There's a this thing of quantity is quality, and that
Right.
is certainly true of data, right? So these models get smarter and smarter with the more data you feed into it, the faster you can feed it. So I think that, and what we also have to understand is that a company like Nvidia, it's not just about the GPUs. It's not just about the software, the servers. It's all about the software stack. It's all about enabling uh, the
Hmm.
the efficiency of that data, the access to that data, the utilization of that data. So very much, what part of NVIDIA's strategy, which is brilliant, is to be able to create these software stacks that are free, that are optimized for GPUs. So from that point of view, absolutely, you're going to want to use that software stack, which is why some of their other competitors have had such a hard time competing with them because of that grander ecosystem, which is critical to getting these efficiencies. And not only that, but in order to expand into the mainstream market, right, you don't have experts and engineers in the enterprise, for example, that's going to be that can take advantage of that deep knowledge. And so, from that perspective, you're going to go where number one, there is trust. Trust is the most important thing to a CIO. So you
Mm,
want to be able to trust your vendors, trust the technology, trust it costs the cost of trust is much higher than the cost of infrastructure.
Hmm. Yeah, that's an excellent point, and we do need to be mindful of that. But again, it is open source, so there's that, and even OpenAI is now closed source. I mean, I wonder if they should change their name because they're now a black box, right?
That's
When
true.
when
But
you
there are
talk
other
about
large language models besides that.
sure,
You've got open source Llama.
Mama.
So there's other access to open source large language models, right?
Yeah, well, and you made a really good point that there is this presumption that bigger is better, and as I mentioned, even Sam Altman seems to realize that's not true. And even though these large language models have stolen the headlines, the fact is that AI models don't need to be large language models. You can have much smaller models trained on very precise data sets, and that kind of gets us into the conversation about data and data quality. Unstructured data has been the redheaded stepchild of the enterprise now for pretty much my entire career. It's been largely ignored. There were a couple of companies that came along. Of course, Microsoft with SharePoint. You've got Dropbox, for example. You have various players who have stepped in, even Amazon with S3, to try to address some of these concerns. And in the first call I ever did with David Flynn about 7 or 8 months ago, we bonded because I ragged on SharePoint. I said I've never liked SharePoint. Is that when I heard about it and I started working with it, I'm like, okay, this is just a sort of file system. And he said it's not even a complete file system, right? So it's like there are all these shortcomings, but geez Louise, if you're going to leverage AI for your enterprise, you're going to want to use your data and you're going to want your data to be not perfect, but close to perfect. You want it to be really pretty clean because whatever comes in is going to go right out, correct?
Well, data hygiene is critical, right? And so, part of the process of it is that, as I said, quantity is quality. But that's stage one, right? So stage one is that let me get as much data as I can, and then you have to find signal within the noise, right?
Hmm.
That's the critical aspect that I absolutely agree. And we have to understand everything has its use, right? So SharePoint has its use. SharePoint, is a collaboration tool, right? That's what it's used for. It's not a file system. It's a database, fundamentally, a database with a lot of unstructured data shoved into it. And so, by its very nature, it's at odds with itself, right? And
Good point. That's a
and
good
so
point.
yeah,
That's
and
interesting.
that's why performance suffers and things of that nature. But it was never meant to be a replacement for file systems. They play very different roles. And when you try to make one work as the other, that's where you begin to fall down, where you get companies who do these global file locking capabilities in order to do collaboration with an enterprise file system. That's where things begin to break down, right? And SharePoint's good at that because it's working at the application layer. File systems work well when they work at the file system layer, right? That's what they
Mm-hmm.
are. So that's what you need to focus on their strengths with. So what's great about Hammerspace is we have a functionality called data in place assimilation, where we can actually, scan third-party data sources, take their metadata, put it into our metadata servers, and then we can now orchestrate that data, move that data wherever you want, including your GPU farms, right, in order to train that data. Whether that's from file systems, whether it's from OneDrive or Dropbox or any of those other data sources that you're talking about. So from our point of view, we can assimilate universally and get all of that into your GPU environments running on our high performance parallel file system, right?
Right. And I know, I'm not sure how much we can say publicly, but I know you are training very, very large language models right now with
Right.
Hammerspace.
That's right.
But I do want to talk about the cost of training because that was clearly the
Right.
part of the news story that was driving this crash is, oh my goodness, these guys did it for so much more efficiently for so less money, which, I'll take them at their word for it. I mean, I'm
Sure.
sure they were clever about how they came up with the calculation, but so are American companies, right? I mean, there's this sort of presumption on the part of some that, oh, anything coming from over there, we can't trust it. It's like, all right, I think there is something to be said for taking it with a grain of salt. But on that training front, I mean, we're making advances on a regular basis in training them faster and faster. And they also did some really interesting things with distillation, right? Where they're using the large language models to train smaller models. And like if you look at Mistral with what they've done with this mixture of experts, I love that model. I think that's going to be the model of the future, right? Where you have some sort of orchestrator and then a bunch of highly focused and specific and fine-tuned agents underneath that do specific things very well. So my point is that guys, we're already getting better at training these models. So that news shouldn't be as shocking as it seems to have been. What do you think?
I agree with you, and as I said, it's about provocative headlines and all of that. What we have to understand too that is there is not a lot of expertise on creating high performance compute environments, right? I mean, it is a finite knowledge base, and so the idea of being able to, especially in when we start pushing this down into the mainstream, right? Right now, a lot of this is by and large in hyperscalers, people who, can invest heavily in the kind of expertise and even attract the kind of expertise you need in order to build these kinds of environments.
Right.
And so, in order to duplicate what they've done, you need very specialized expertise in order to do so. Let's take it on face value that everything that they say is accurate. How does somebody else duplicate that in their environments, right? So,
Yeah.
you need well-worn solutions you can rely on, solutions that don't necessarily require this very niche capability and knowledge, right? So, and oftentimes you're going to rinse and repeat. Oftentimes, what we see with our customers is that they're going to leverage or already leveraging the cloud, which that they can get access to these solutions and not necessarily doing it within their own data centers or creating a hybrid model, right? So so all of those things are part of it. So yeah, I think that it's that there is an inevitability towards commoditization. How
Hmm.
long that takes, I think, is what's in question, right?
Yeah, that's an interesting point. We already have a great question from the audience. An attendee is asking, don't parallel file systems struggle with complex metadata management, consistency issues, and higher costs compared to traditional file systems? What do you think about that?
Absolutely. And what's great about Hammerspace is that we are a metadata-driven parallel file system. So, in recognition of that, what we've done is we've disaggregated the metadata plane from the data plane, which allows us to, in a RocksDB, a KV store, better handle and manage metadata in a way that traditional file systems in which metadata and data are, bonded together that
Right.
doesn't allow them to scale or manage. We actually can manage data. The way we manage data is through metadata. And so you can, at a file granular level, completely control the pipeline workflow of data based on any metadata attribute, file name, file type, file size, creation date, modified date, last access date, and you can customize our metadata in order to control it. So you tag, so if a researcher or a scientist, has a set of files that they want to create certain rules around, they can custom tag that with whatever makes sense to them in human normal language, and then control data that way too. So yes, we have concentrated and focused on the fact that metadata and managing metadata is critical to the pipeline.
Yeah, and I often make the comparison to what Snowflake did just because they were very clever about separating compute and storage. And
Mhm.
I'm a data warehousing guy. I got into this industry 25 years ago through a business intelligence consultancy called Damon Consulting. So I started wrapping my head around ETL and ELT and all this data movement and thinking to myself, this has got to stop. In fact, in the first year of DMRadio in 2008, I talked about how this madness of moving data around and around and around and around is just crazy for lots of reasons. One of which being, I would ask all sorts of vendors, do you have a strategic view about which data sets went where, and specifically which fields? So in customer data, it could be in multiple different systems. Are you actually moving this multiple times? And for little effect? And the short answer is, well, yeah. And they all would say, no, it's in the roadmap. We're trying to be able to do that. And I understand how we got here because the data warehouse took off. People suddenly realized, hey, this is very cool. Now we can analyze our data. But in the old days, you had to strip out all the context to get the numbers through the thin wires to the expensive processors to expensive storage. Well, all that has now changed. You don't need I mean, we now have fast processors and arrays of processors, like all these things. So all the dynamics change. And we got our first break coming up in just a second. So I understood data warehousing and I understood ETL, but I thought to myself, gosh, there's got to be a better way to do this. And there were
Right.
many attempts at that data virtualization. Companies like Denodo, companies like Composite Software, these are all clients of ours over the years. So I recognized they were trying to work on that problem, but it was difficult. A lot of intelligent caching is what they're trying to do. And you just wind up with performance issues. You wind up with quality issues. You wind up with timeliness issues. And these are all huge factors to deal with when you're trying to crunch numbers at scale. Well, guess what, folks? Like, we've never needed to crunch at scale like we have in this era of training AI models, especially large language models, again, with billions of parameters. Just do the math. If you got to do 11 hops for, for a billion parameters, that's 11 billion hops. If you can cut that down to 4 billion, that's a huge savings in time, in energy, in compute power, all that fun stuff. Folks, don't touch that dial. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio with Tony Asaro from Hammerspace. And I love the name of the company. I'm fascinated by what these folks are doing. I was so excited because I got to tell you, I sent them an email yesterday morning saying, hey, we should do a show on this topic because DeepSeek is blowing the world's mind right now. And I think that we do all need to calm down a little bit because, number one, it's a fantastic innovation. I mean, really, it's very, very impressive. They're number one on the App Store, right? Just like boom. Number one, people love this stuff now. They're fascinated by large language models. And why wouldn't they be? These are amazing technologies. And I joke often that one of my good friends is a guy named Dr. Usama Fayyad. He heads up the Institute for Experiential AI at Northeastern Institute, so not too far from Northeastern University, not far from you. And at the beginning of last year, he said, these models are too big. We don't understand how they work. I'm like, what? You're the guy running this institute. And he's been doing this stuff for a long time. He was at Yahoo when they rolled out Hadoop, right? So, like, I watched the whole Hadoop movement. I think we learned a whole heck of a lot about federated systems and parallel processing. And to your point, that's a whole separate set of challenges to deal with. But, kind of getting back to the impact of DeepSeek, I think a lot of it is psychological. And I think a lot of it is really not on target in terms of any sort of long-term movement. Because in my opinion, I'll get your thoughts on this. What I said on the Big Bytes podcast with Ocient earlier this year, and they're doing hyperscale data warehousing, trillions of records on ingest using NVMe, which of course David Flynn had something to do with in his past company, as I recall. He's the CEO of Hammerspace. I think that we have just entered an era of hyper accelerated innovation, and we're going to see amazing things spin out of this. This is not the end; it's the beginning of that phase. What do you think, Tony?
Well, I agree. I think we're on the threshold of it, and you're going to see sort of game-changing things popping up here and there in a way that you and I have both been in the industry for decades, right? So we get used to sort of this pace of innovation. I think that
Right.
pace is like it's something that we're not going to recognize because like, whoa, this is a new game. But I'm also been around long enough not to be overly impressed with a single point in time. It's
Hmm.
it's 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 good to be mindful of it, but not to overreact to it as well because what we still have to deal, at least for now, with the laws of physics, right? So
Hmm.
that's an important aspect of it. But I think that that innovation is going to pop up, and I think that AI is going to drive that on both ends of the spectrum, both from in terms of users of it and also creators of it and the ecosystem around it, right? So it becomes this sort of self-driving thing, right? Whereas not only are people, technologists who are making AI better, that AI in turn will make whatever they're creating better as well. So it's circular. It's a virtuous circle in that sense.
Interesting. Yeah, no, I think that's a good point. And what do you think about pressure to maintain open source policies. And, of course, OpenAI was open source. They changed their mind. It's now a black box, which I find really rather curious because as a black box, they would seem to be boxing themselves out of any number of enterprise use cases, right? Because auditors are going to want to come in and say, "Hey, how did you get this answer?" That's hard enough with the open source version. I mean, it's
Right.
already very difficult to ascertain what's actually happening under the hood there. But what do you think
And
about pressure on OpenAI, for example, to go open source?
well, a few things there, right? So, OpenAI really, I think, in many ways, look, it's interesting. Technology and the things that we do, right? Really impact the world in on a massive scale, and yet most people are not plugged into it, right? So, you must go to parties, and people are not in the high tech industry. They're like, I don't know what you do. What do you do? I don't know. What's all this AI stuff, right? So the vast majority of people aren't plugged into it. OpenAI made it mainstream. It made it so that every single person in the world understood what the impact of AI could be. So it created that common ground that everybody understood it to some extent, right? So I think it triggered, the whole momentum here. And so that's what they brought to the table. And since then, so much investment has gone into it that the inevitability of open source alternatives popping up everywhere, right? It's just part of it. Whether they cave into or are overly influenced by the fact that there are other models that are open source, it remains to be seen. But that pressure is there. What I do want to mention about open source, right? Because there are other open source in our world. There are other open source file systems that use standard based stuff and everything, but it's also about the community that supports those things, right? So the community has to be healthy and thriving and supportive and reactive and communicative and all of that. So just kind of doing a broad brush of, hey, it's open source, so therefore it's better. That isn't the case. It has to be well supported and adopted widely. You're on mute, Eric, by the way.
Sorry, good point. The dogs are barking. um, that's an excellent point, and I think hats off to Mark Zuckerberg. And I kind of think that he may have done it because he was under pressure because he saw these people doing such a good job with OpenAI and some other environments. And obviously, these guys compete with each other. But
Well,
to make
hats
it open
off to him.
source,
But hats off to him. But then we'd have to see that weird haircut of his. So.
yeah, that's right. It is getting a little stranger, isn't it? It's not as bad as Jack Dorsey, though. I don't know if you saw him, like in some of his later days. Like, dude, where are you dialing in from, man? Wow.
Sorry.
God bless him, though. And I like to rail on Jack Dorsey for killing Vine because you look at TikTok, how TikTok took off. We had TikTok. It was called Vine. Twitter bought it and then stuck an ice pick in its neck, and now it's dead. And then
Right.
the CEO, who was a young guy, went out to another company and then died like a couple years
Yeah.
later. So it's just like, geez Louise, that to me was a travesty of decision making in IT. It had a huge impact. Now TikTok is dominating the world. We could have had that technology had they not killed it. But anyway,
But that's a great point, though. I mean, so we've seen things like that in the industry time and time again, right? And oftentimes it comes to bad choices, right? You made the bad choice at the wrong time, right? If you just
yeah,
And perhaps that is what's going to be confronted with OpenAI right now, and the fact that there are so many open source choices out there that
right.
people can use as alternative. Some of them with more efficacy and again trust than others.
Right. No, this is an excellent point. And I'm reminded of Hadoop again, just because of all the excitement around it and the I think lack of appreciation for the specialized use cases where it does provide tremendous value. We're seeing that whole conundrum resurface. But do you remember how at one point there were like seven HDFS distros? And
That's right.
then it was like six, then five, then four. And it's like, okay, guys, like, do we really need to be managing our own distro of the Hadoop distributed file system? And the short
Right.
answer, of course, is no. Right?
Yeah, and that's where you get sort of open source becoming actually not necessarily a panacea for everything. As a storage guy, right, I have to go back to this notion of Ceph, right? Ceph was one of those things, and people started just saying, "Hey, this is free." And I can use it everywhere. Well, no, it has a very specific use case, and trying to use it everywhere is actually going to hurt you more than it's going to help you.
Hmm. Now, if you would just dive into that real quick, because I remember the excitement around Ceph. That was Red Hat, wasn't it, that rolled out
That's right.
Ceph?
That's right. Yeah, and So Ceph, object store, and yet people started to using it for highly transactionable, trying to make it into a file system. Those are very two very different constructs. One does not replace the other per se, and so I knew of large enterprises just adopting it everywhere and then regretting it afterwards, right? And again, it's not that it has no value. It's just that you have to understand what that value is and then focus on it, right?
Yeah. No, it's a good point. We got a couple other real good questions
Yeah.
here from the audience. One question is, oh, okay. So my question is, with the leap on DeepSeek, do you think the learning curve for AGI will be faster, and how can governance come in play or in place to make sure that models are safe? My take on AGI is that, we have these reasoning engines now. That's what DeepSeek is supposedly doing, and it's a chain of thought kind of process where it'll examine a situation, come up with a possible number of options to go, then examine those, almost like a chess player does. And I'll throw out a funny joke that a friend of mine, Alex Husky from ExxonMobil, emailed me yesterday. He says, yes, these things are amazing, but it takes megawatts of power to run them and to beat Kasparov's brain, which only uses 14 watts. Right. So it's like, yeah, the human brain is still pretty good. It's not that you need it to do all this stuff, but so in my opinion, AGI, I don't think that computers are going to become sentient, but they can seem sentient because they can speak in languages. And now you can have robots that have this natural language capability to seem like they're real. That doesn't make them sentient. But what do you think about how this changes the game and accelerates the movement towards much more intelligent systems?
Well, first, I would argue that our intelligence is artificial and simulated too. So so so
That's a good point.
not telling the difference between those two things. It's just going to be a matter of physics at that point, and when we get to quantum in the mainstream. But yeah, I think that it's look, it's double-edged sword, and technology has always been a double-edged sword all along the way. And so from the perspective of the thing that you invent that can cause some of these issues is also the thing that's going to help to ensure its security, right? So it's always a race. And so you have to make sure that the good guys are just one step ahead of the bad guys every step of the way, and it becomes this ongoing challenge, right? But that's what you do. You use fire to fight fire.
Right. Well, and this gets back to open source. And I've been a big proponent of open source for about 20 years now. It was around, yeah, it was around 2005, in fact, that I really dove into it. I was working for the Data Warehousing Institute up in Seattle. I had just left New Orleans right before Katrina hit, and it's a long story, but I decided to research open source. And I remember thinking to myself, the combination of open source and service-oriented architecture will spell trouble for big closed source enterprise software companies sooner or later, right? Because you figure if you can easily mix and match components or modules within your stack, that gives you agility. It allows you to avoid vendor lock-in. And I think that maintains its power today, right? The power of community, the power of open source. I mean, there are lots of mantras or cliches about it, like bad code goes away. But there is also this downside
Eventually.
that eventually, right, and it won't go too far because then it's certainly you got to make some money on this stuff, right?
Well, so I think that we also need to make sure that we don't equate open source with standards. So there's
Hmm.
standards based, right, where that you make sure that you adhere to standards versus doing things that are proprietary within the communication protocols in which you talk to and between systems, right? So try to adhere to standards as much as possible, and then if you are going to create proprietary technologies that are your core IP and special to you, that you make sure that you're living within an ecosystem of standard-based communication, so that you can open yourself up to the larger world, right? I think that's
Yeah.
too.
Oh yeah, standards. I mean, what's the old cliche about that? The beautiful thing about standards is there are so many of them. right?
That is a good point. Yes.
But we do have some really powerful standards.
Yeah.
HTTP is a standard for crying out loud. I mean,
Right.
HTML is sort of de facto standard, and you're starting to see that. I mean, I remember the WSDL days when they said it was going to be SOAP instead of REST. Well, guess
Right.
what? REST won that battle, right?
Right. And NFS 4.2. We love NFS 4.2.
That's funny. That's a good point. And
Yeah.
we do have a couple other questions coming in from our virtual studio audience. And folks, if you want to be part of these shows, send an email to info@dmradio.biz. Today we're talking to Tony Asaro of Hammerspace about the DeepSeek deep dive and what just happened here. And we'll get in the next segment. Let's get deeper into the parallel file systems as well and what that all means. But Tony got about a minute and a half left in this one. One question just surfaced here of the data, whose data is being used. Of course, on all the TV news channels, they're saying, oh, if you put your data in there, it's going over to China. Yes, that's true. It's also going to Google and Facebook and all these guys all the time. And that is an ethical question that we need to get to the bottom of, right? Real quick.
Well, yeah, I mean, so data is very accessible, right? So there's lots of data out there. If you're voluntarily giving your data, just be aware of that. I think that people just get numb to that, right? Just whether they assume bad actors or not, I think that at some point they just don't care, right? They
Right.
just they just will do it. And I think it's an issue of it's sort of this thing where, if you want to break into someone's car, you can break into someone's car. It's just a matter of there's so many cars, is it yours that's going to be broken into? So the idea of it is that it's a numbers game at some point. But
Right.
yes, I would be, I personally would make choices about where and who I trust. And again, whether it's individually, and the thing about things like security is that it is something that everyone is conscious of. It affects everyone, whether you're
Right.
a consumer or a CEO or a founder or it crosses the board. And
That's right.
so trust is the most important thing where your data is concerned.
Yeah, and we'll pick that up after the break. That's an excellent point. We have a question about that too. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio. We're talking to Tony Asaro of Hammerspace, and I'm having some fun technical issues here with my screen, but we'll be all right. We're talking about DeepSeek and a deep dive on all this. And security, of course, is a huge concern. Why would security not be a concern? One of our virtual studio audience members is asking about that. Yeah, security is an issue. It's a huge issue. And you could argue that if you're going all the way over to China, you are exposing yourself to other security issues for sure. But there are security issues everywhere. And I guess this gets back to the trust paradigm that you keep bringing up, right, Tony?
Well, that's exactly right. So, when talking to executives, technology executives, this is the most critical thing. It's trust, it's risk, and if you can, they will make choices based on that, even if it comes at a higher cost, even if it comes at a curve of efficiency. All of those things are critical because once you've lost trust, then there's nothing that can impact your business and negatively as much
Yeah.
as right.
No, that's right. I mean, it takes years to build up a reputation, moments to shatter it
Right.
overnight. I mean, I do think that most people are kind of jaded, like you said, they're kind of numb to issues like data privacy and data security. And you're numb to it until you get bitten by it. And then, of course, you're very unhappy about that. We
Right.
do have some folks asking, is DeepSeek's R1 deemed safe? What would it cost to run it locally in U.S. data centers? Well, folks, look up a guy named Rob Tiffany, Tiffany, I believe, on LinkedIn. He just posted today a whole series of specs about how you can download DeepSeek and run it on a machine like that costs like $6,000. You can have this whole thing, this big honking LLM on-prem. And that's the crazy thing. I guess one question I'd throw at you, Tony, and you may not know this, but um, even though you're running it on-prem, at some point it could make a call out through an API to a server somewhere, right? I mean, or what do you think?
Yeah, I mean, yeah, you could probably you put it on machines that allow you to ensure that that doesn't do that, right? So I think you can put some controls around that as well. And anybody who is going to be doing that, because I don't imagine non-technical people to be going out of the way to do that. I would assume that those people know how to make sure that that they're air gapped, right? So that that doesn't happen.
Right, as long as you don't touch the internet, right?
Right. Yeah.
You should be okay. It is amazing to see what these things can do. I mean, the amount of knowledge that they have is gobsmacking, and and the thing too is they're getting better by the day, quite frankly. I mean, this is so there's this whole argument of, should we get a small language model and put it in our data center and control it and own it and run it? I think that's a very clever idea, but then you are missing out on some of the innovations that the bigger guys have from Anthropic and OpenAI and even Google with Gemini. What are your thoughts on that, and how should a company distill this and make sense of it and make a good decision for their needs?
Well, I can't speak for some of. Oh, I'm sorry, my light just went out. Some of the priorities around that, but again, I think that number one is that depending on where you sit in the kind of the business ecosystem, right? For the most part, I don't think that bad actors care about you, right, or care about your data, right? They don't. So for people to be overly paranoid about that type of thing, it is a numbers game, in fact. The other side of it is that, again, it lends itself to expertise. There's not a lot of expertise in this space. And so people are going to go where things are easy, simple, where
Mm,
they know that they can have, access to a larger community to help them if they need to, whether that is, based on relationships they already have with certain businesses, with the fact that they are, you know, um, I'll just give you an example, right? It is in the IT infrastructure world. It is, and I don't want to create too much controversy for me to say this, but it is much less expensive to run all of my IT infrastructure in house, right?
hmm
But number one is that it's harder and harder to get IT expertise in order to run all of those things, right? So I don't necessarily have access to all the smart people I need in order to run it. Um, so that's why the cloud has been so successful, is that companies are running in the cloud, running their infrastructure, a large part of it, not all of it. And even though the cost of it is much higher. So, there you go, right? It's cost versus of manageability. And then
Yeah,
again, it's
simplicity.
simplicity and
hmm
scalability, and
Right.
all of that. So, there are lots of other factors that play into this.
Yeah. Oh, there's no doubt about it. And David Flynn on that webinar I mentioned, folks, you can look it up, All Access Pass. It's on YouTube now on our channel, which is Inside Analysis. You can look it up. He made this really interesting comment. He said that this kind of robust parallel file system that you've now built, where you've abstracted all the metadata and metadata management out of the storage layer and into this abstracted layer, thus opening up a massively parallel data path to move data around. And that's what's happening. He said if that technology had been around, let's say 15 years ago, we might not have needed to dumb everything down for cloud. Because if you think about, in order to refactor, and Kubernetes is a big part of that, obviously, refactoring for Kubernetes, but also just refactoring for cloud, well, APIs and REST interfaces are kind of like toll gates. They're toll booths for functionality. And if you really get down to brass tacks, it's easier and faster to have everything in your environment, not have to constantly be going through these toll booths just to get stuff, to get API calls, etc. So I thought that was a very interesting comment, and I see how this kind of solution is a massive solution for hybrid cloud, because hybrid cloud is, if you do it wrong, you're screwed. I mean, it's just so painful. I've heard terrible stories of companies not doing it properly and just getting absolutely pounded. But what do you think about that? Is that viable? I think it's fascinating.
Well, yeah, absolutely. I mean, hybrid cloud, I think, is critically important because, especially and from our point of view, because we've been doing hybrid cloud for many years, um, the AI and training, and getting access to GPU resources is the killer app for us in this space, which is what we're finding. And the idea is that, uh, it's interesting, and we're not storage, right? And we're not a storage based file system. Those folks think about storage. What we think about is data, and that's
Hmm,
the huge difference. And one of the key things about that is
interesting.
eliminating data gravity, right? This notion that your data is trapped within your storage, right? In traditional storage systems, the data is subordinate to the infrastructure, With Hammerspace, our philosophy is that the infrastructure should be subordinate to the data. So that's
Mm,
why hybrid cloud needs to be free of data gravity, so that from the applications and the user's perspective, they shouldn't
right,
have to care where it's located. All they
right,
need to know is that they got full access to it, and allow the technology then to make sure it's where it's needed when it's needed. And that's
right.
really the key to hybrid cloud.
Well, and that's where this declarative unstructured data orchestration comes into play because you can have, for example, like if you're doing, if you're trying to pull out of one expensive data center or one expensive cloud, for example, or a contract comes due, whatever the use case may be, you can set all that up and have it running in the background. And then if some senior executive needs something else done, that can jump to the top of the queue and take precedence. So it's almost like, when emergency vehicles go by, you pull to the side of the road and the emergency vehicle goes through. You've got that capability with this sort of comprehensive, declarative, unstructured data orchestration, right?
That's right. Exactly right. It's all about orchestration. And look, S3 in its very definition says simple. And guess what? Data isn't simple, right?
Hmm,
There's a lot of complexity to it. There's a lot of nuance to it. The key is not being overwhelmed on, but creating a platform that actually can make sense of it and can control it through metadata, right? So that's the key. But you're absolutely right. But we also understand that it is a multi-protocol world. And
right,
so, the two
right.
key protocols that we're seeing in the AI space are NFS 4.2 and with S3. So even though S3, isn't a file system, has limitation, it has been widely adopted. And so, the idea of with Hammerspace is that we can support S3, the protocol, but we're doing object on file. So you get all the benefits of an intelligent, well protected, secure, and serviceable file system, but we are able to take all of those objects and manage them in a way that a file system does. And so you get the best of both worlds. And I would say that even you get an elevated value of combining those two things within Hammerspace.
Hmm. That's very interesting. I mean, to your point, data is the ultimate digital asset. It is what you need to run all these algorithms. It's what you need to run every program,
Right.
ERP, CRM, whatever it is. I mean, there's functionality built around the data. And we had a show a couple weeks ago with the folks from Decodable, and I just had a sort of aha moment because they were talking about different models and how you get challenger models, and you want to be able to swap them out. And I said, yeah. And the thing is, you can swap out a model, you can't easily swap out your data. Right? I mean, that's kind of the issue here. But folks, don't touch that dial podcast bonus segment coming up. You're listening to DM Radio. All right, folks, time for the podcast bonus segment here on DM Radio with Tony Asaro of Hammerspace. And we're talking about these parallel file systems. And the other thing that really struck my mind, talking to David a few weeks ago, was about file copies. You think, I mean, I've heard research where they estimate it's like 7, 8, 9 different copies or even 11 different copies of data all throughout your enterprise. Well, that's a risk. And as I think about what you folks are doing, one of the big use cases that popped in my mind was GRC, governance, risk management, and compliance, because and hitherto, I mean, with SharePoint, they were leaning towards this. There are some other players have come along over the years to try to address this issue. But to me, a parallel file system is probably the best case scenario for being able to catalog all your data, understand how many copies you have of your data, because you don't need more than three. I mean, the Hadoop instance defaulted to three, right? To three files, whatever, for each piece of data that you have for each file, three copies, I should say, across the
Yep.
different nodes. So if one goes down, but geez, man, when those nodes went down, like this, it would screech to a halt. That's not very usable in the real-time analytics world. But to me, that is a fantastic use case because, again, if you want to leverage AI and you're going to use your corporate data, you need to get it in order. Data hygiene is what you called it, right? What do you think about all that?
Well, I think of a few things, right? So, a parallel file system is really good with AI workloads because those AI workloads are highly parallelized, right?
Right,
So it's
right.
not about, a single file performance or a single node performance. It's about parallelism. The analogy is easy, right? You don't care about how fast that Ferrari can go. What you care about is you've got, as many lanes as you need, so you're never in a traffic bottleneck. Because if you're in a traffic bottleneck, that Ferrari is not going anywhere,
Right.
right? The
That's right.
idea is, yeah,
That's
exactly.
funny.
So the idea is parallelism allows you to have as many lanes as you want, so that you never run into that situation. In terms of creating copies, there's different, different versions of what that means, right? I might want to mirror lots of data so that I can get more performance. So yes, it's the
Right.
same logical file system, right? Although there are other replicas of it that are transacting with the applications above in order to use it. So that's a very practical use for it. But where you get copy sprawl is when you have lots of copies in different locations, or a file that gets copied in different locations and everybody makes different changes to them.
Right.
And
Right.
suddenly now you have all of these entities that started out as the same thing, as one
Right.
thing, and then became dozens of things. And then you get a lot of wastage, right? Because now you've got copy sprawl. It's difficult to manage. It's a difficult control. The deltas are not merged. And so now you've got this runaway train. And one of the things that Hammerspace has done, right, is that file, because we are metadata driven, that file, regardless of how many replicas of it as there are out there that have been made and been accessed to the metadata, it's the same file. So logically, it's the same file, although it's in multiple different locations, right? And multiple users have been accessing it, or multiple applications have, so that you
Hmm.
don't get that copy sprawl. And then so you can then make sure that file remains that file logically throughout the file system.
Yeah, right. No, that's a good answer. And we only got about 4 or 5 minutes left. I'm wondering if you can get into some detail for my edification and also the audience about this work that you've done in the Linux kernel, where
Yeah.
what they've done, and correct me if I'm wrong about this, is because you've abstracted the metadata management out of the storage layer into Hammerspace, you are then you're then able to affinitize when the the data that needs to be processed is on the GPU server itself. And so it doesn't have to go out to the network. It doesn't have to go to various storage arrays. It just goes right through the, what is it, PCIe or something, which is like direct access. Can you explain what you did in the Linux kernel to enable that?
So yeah, so again, I talked a little bit about standards based. So there's nothing proprietary here that Hammerspace has to put into the servers in order to make this work, right? It's built into the operating system. So that's critically important. And this is what we refer to as tier zero, using
Right.
storage, the local storage inside of the servers, as a shared network resource, so that it's not stranded, it's part of a bigger pool. And because of our data orchestration, we can move it outside of these systems, so that they're not trapped. It's not, there's no data gravity to it. And the point is that you are now getting local I/O to that system, and there's lots of ways that this improves performance. Number one is that you now have much more resources to get access to this data, because a centralized storage system has so much network you can get to it, all vying for the same processor, all vying for the same set of disks and things of that nature. So you get much greater performance just by using tier zero within the local servers. And then yes, this process that we call affinitization, that allows you to say, okay, the client and the data are co-located, so that you don't have to go out through the network. And all you need to do is that metadata communication to the client, which is extremely fast, to find the location of that data. So the sum of that is that you use capacity that you've already paid for. That, by the way, the GPU servers have, right today, default 2 drives in there. In the future, it'll be 4 drives. These drives are going to go from 60 terabytes times 2 to 60 terabytes times 4. And then you're going to have 122 terabyte drives. And then you're going to have 244 terabyte drives. And suddenly you've got a petabyte of stranded storage that you're not going to be able to use any other way, except for maybe some scratch space. Whereas Hammerspace says, no, let's give that's an asset to you, that we will allow you to be able, or enable you to use as a shared resource, as part of our parallel file system. And it does not preclude you using external storage. In fact, the whole notion of calling it tier zero implies there are other tiers, right? And so use this as your performance tier, perhaps use something else as your capacity tier, or have various degrees of performance tiers that you want to put into your environment. By the way, That tier zero capability also works in the cloud. When you rent GPUs in the cloud, GPU servers in the cloud, you're buying that storage and you're not even using it.
Wow, I didn't know that. So,
Yeah.
I mean, so typically if you buy, real quick here, got a minute left, you're renting a GPU server in the cloud. Do you
Right.
typically, I mean, do you have to say, I want that whole server and therefore I get to use that storage, or how
No,
does that
you
work?
you rent that server, you get that storage, you're just not using it, right?
Hmm.
And now what people do is they use instances to create external storage, and they're paying extra for that.
Wow. Well, folks, these gentlemen and ladies are up to some very, very interesting stuff over at Hammerspace. Look them up online. Send me an email if you want to be on the show, info@dmradio.biz. We love to know what you want to know. Great questions today. Thanks for sending those in. We'll maybe address some of those after the show. But this has been a fascinating episode. Thank you, Tony Asaro of Hammerspace. We'll talk to you next time. You've been listening to DM Radio.